This call is now being recorded.
Is it my voice is breaking a lot? Everyone? Okay, then you you just leave the meeting and rejoin the meeting once again. Okay. So let's learn about types of relations. The first type is inverse relation. Fine. So write it down. Let R be, let capital R be any relation from a set A to set B. The inverse relation of R is denoted as R inverse which is the relation from set B to set A, and it is defined as R inverse B comma A, where AB belonging to R. Right. That means if AB is a pair in R, then what is the pair in R inverse? BA. Write down. So write example. Suppose our relation is defined as 1 1 1 2 3 1. Right? Then what would be R inverse? 1 1. What is the inverse image of 1 1? You have to do the inverse image of 1 1, and that is 1 comma 1. What is the inverse image of 1 2? You have to just write reverse back, that is 2 1. And what is the inverse image of 3 1? That is 1 3. So these are the images of inverse relation. So write down a note. If I say that X is related to Y, then it is similar to say that Y is inversely related to X. But obvious, domain of R would be equal to range of R inverse. Range of R will be equal to domain of R inverse. And quote, R inverse is R. Is it okay? Okay, can I remove this? Okay. Now next relation is the identity relation. So second relation is identity relation. What is identity? That if I'm having some elements, and if I enter it into the function, and if I'm having the same element as the answer, then that is called the identity element, right? So write down definition. Yes, self relation. A relation R in a set capital A is said to be identity relation. Identity relation is written as I suffix A, which is defined as x comma x, where x is belong to the set A. For example, if I am having A equal to 1, 2, 3, and I have to find IA, then what would be the members of IA? Yes, anyone? You can unmute yourself and give the answer. If I'm having 1, then I'll be getting images 1. If I'm having 3 images 2, then I'll be having images 2. And if I'm having 3, then I'm getting 3. So this is the identity relation. Okay. Then the third type of the relation is an array relation. An array relation. So write it down. Let R be a subset. Let capital R be a subset of A1 cross A2 cross A3 cross AN. Then R is called an array relation. R is called an array relation. for n equal to 1. That means if R is a relation on set A only, right? Then R is called unary relation, right? So then R is unary if n equal to 2. Then R is binary and n equal to 3, then R is ternary relation. Right, so if R is a relation defined on 3 sets, then we can say that it is a ternary relation if it is defined on the set A and B. That is the general practice we are doing in the 4th semester discrete mathematics. So R is called binary relation, and if R is defined on only one set A, then it is called unary relation. Fine. Write down example. Let A is equal to 235 and B is equal to 6, 8, 10 and relation R is as for every xy belongs to A cross B, xy would be in R only and only if x divides y. And generally, we are doing the practice that denominator is the divisible term, and it divides the numerator. But here, the numerator is dividing the denominator, and also find R inverse, range of R inverse, and domain of R inverse. Whenever you write it, please let me know so I can move ahead. Okay, so let's find the answer. Okay, what was your A? A was 235. Just a second. A is equal to 2, 3, 5. B was what? B was 6, 8, 10. And relation was defined as x divides y, right? So what can be the relation? 2, 6. 2 is 2 divides 6. So 2, 6 is in the pair. 2, 8, yes. 2 divides 8. 2, 10, yes. 2 divides 10. Then 3 divides 6. So 3, 6. 3 does not divide 8. 3 does not divide 10. So that would not be coming as a pair. Now 5 does not divide 6. 5 does not divide 8. But 5 divides 10. So 5 and 10. So these are the relations. Now you have to find R inverse. You know how to find R inverse. Okay, I'll be asking any 2 students of your class. So be ready. You have to define R inverse and you have to find out all the answers, that range of R inverse and domain of R inverse. Yes, if anybody is having any question, then please ask me. Just a second. Okay, so what is R inverse? R inverse would be 6, 2, 8, 2, 10, 2, 6, 3, and 10, 5. What would be the range of R inverse? Range of R inverse is equal to domain of R. What was the domain of R? That is 2, 3, 5. This is the domain from A to B, because R is a relation from A to B, right? R is a subset of A cross B, that we know, because it is given in the illustration. Now you have to find domain of that would be equal to range of R inverse. Answer, range of R. Domain of R inverse will be equal to range of R. What is the range of R? Range of R is 6, 8 and 10. Is 6, 8 and 10. Are you getting my point? What we have learned up to now? Okay. Okay, yes. Just a second. I'll be continuing in 5 minutes only. I'm continuing the lecture next 2 minutes, okay? Just a second. I'm really very sorry. My power was cut. That's why I have to come over here. Okay, just a second. I'm sharing the data right now. I hope you are able to see the screen now. Fine. So you have written it, right? Okay, fine. Now you will have to write this question. Let A, this is the example, let A is equal to n-array relation is nothing but n-array relation is the subset of A1 to AN. If a relation is a subset of A1 cross up to AN, right, then it is called n-array relation. Fine. If that is the definition. Relation, what is the relation? Relation is just a subset of A cross B in simple language, right? So if n is equal to 1, we have taken one set only, then it is called unary. N equal to 2, then it is called binary. And n equal to 3, then it is called ternary. And if n is up to n only, then it is called n-array relation. Okay. So write down, let A is equal to small a, small c, small b, small c, and small b. Then find IA. Right, now this is the inverse relation, and you know how to find inverse relation. Okay, you have to find it. Chalo badaye karwanu છે. Yes, you found the answer. Let me ask you. Jenny, unmute yourself, beta. Jenny Makadia, unmute yourself.
Yes, ma'am.
Yeah, what is the answer?
AA, BD, CC, and DD.
Yes, very good. Okay, fine. So write down next properties of relation. Properties of relation. So first property is reflexive relation. So write it down. Reflexive relation. This is reflexive. So write down a relation. A relation capital R defined on relation capital R defined on set A is called reflexive relation if for every A belongs to A that is A comma A belongs to the set R. Right. Suppose I am taking the set A is equal to 1, 2, 3. Then I am writing a set and you have to tell me that is it a reflexive or not. Okay. So 1, 1, 2, 1, 2, 2, 3, 1, 3, 2, 3, 3. Is R a reflexive relation or not? Ravindra? Ravindra? You have to unmute yourself and tell me the answer. Ravindra, are you there, beta? Rajesh?
जी मैम जी मैम
Yeah, is it a reflexive relation or not? What is the definition? That A comma A should belongs to R. This is the definition, right? So what are the members of A? That is 1, 2, and 3. Is 1, 1 there? Yes. Is 2, 2 there? Yes. Is 3, 3 there? Yes. So this is the reflexive relation. Fine. So now my question is that, okay, but unmute yourself. Now my question is that, what is the difference in identity set on A and the relation which is reflexive? What is the difference between reflexive relation and identity relation? Right? Now, what is identity relation? Identity relation is having only 3 elements, that 1, 1, 2, 2, and 3, 3. Right? While reflexive relation can have other elements as well. But it should have 1, 1, 2, 2, and 3, 3 also. If anyone is not there, suppose 3, 3 is not written over here, then it is not a reflexive relation, because 3, I'm not getting any image for 3. That is 3, 3. If there is no 2, 2, then it is not the reflexive relation, because I'm not having 2, 2. Fine. So it is very must for us to find the relation which is having same images, that is 1, 1, 2, 2, 3, 3, and it can have other elements as well, and that is why it is called reflexive relation. Fine. Yeah. Okay. So next is irreflexive relation. Irreflexive relation. Fine. What kind of the what are the types of the relation that we called irreflexive? Yes, anyone? If ARA is not there, right? If I'm having all the members without ARA, that is A comma A, that is 1 comma 1, 2 comma 2, and 3 comma 3 are not appearing in the relation, all other relations are appearing, then it is called irreflexive relation. Fine. So write down a relation capital R, a relation capital R on a set capital A is called irreflexive if A is not related to A. That means you have to write down this one. For every A belongs to A. That is A comma A does not belongs to R. For example, if my set is AB, the members of the set are AB, then the relation is irreflexive, because it is not containing the member of A comma A. Okay, you have to write the example as well. So at the time of the examination, You remember everything. Okay. Now, non-reflexive relation. So a relation which is not irreflexive and a relation which is not reflexive is called non-reflexive relation, right? So write down a relation which is not irreflexive. I'm sorry, not neither reflexive nor irreflexive is called non-reflexive. So this is non-reflexive relation, right? So you have to write down the example as well. Fine. So these are the types of the relations. Fine. So if you're having any doubt in this, then you can ask me. And as sir has told, your mid-semester syllabus is Unit 1 and Unit 2. Fine, and we have uploaded the PPTs regarding Unit 1 and Unit 2 in your e-content. So you don't have to worry, you just have to see the PPTs